The Use of Machines by L. Owens. Work and machines. Defining work. What do you think about when you hear the word work? Do you think of chores you do around the house, such as taking out the garbage, setting the table for dinner, or making your bed? Do you think of different jobs that adults have, such as truck driver, computer programmer, or nurse? All of these examples fit the meaning of work as we use it in our daily lives. We're going to take a closer look at another way to think about work. In science, work is the use of force to move something a certain distance. The force, or pushing and pulling, is applied to an object. You can tell that work has occurred when an object moves. If the object doesn't move, no work has occurred. If you use a wheelbarrow to move a heavy load across your yard, you have done work. Work was done because the load moved. Suppose you tried to lift the load out of the wheelbarrow, but it was too heavy. No matter how hard you push or pull, you cannot move the load. In this case, you have not done work because the load did not move. Work can be measured. You can find out how much work is done for a given task. All you need is to know the formula that scientists use to measure work. Work equals force times distance. Work is measured in a unit called the joule. The abbreviation for the joule is J. 1 joule equals 1 Newton times 1 meter. Let's use the formula to measure some work. You moved a wheelbarrow a distance of 20 meters. You pushed with a force of 10 newtons. The wheelbarrow moved 20 meters. The work done was 10 newtons times 20 meters, or 200 joules. Machines. The basics. What do you think of when you hear the word machine? Something big and noisy, such as a bulldozer, or even bigger and noisier, such as an airplane. Both of these machines are made up of hundreds or even thousands of moving parts. Did you know that some machines don't have any moving parts? It's true. By definition, a machine is any device that helps people do work. A simple machine is a tool or device made up of just one or two parts. Think about some everyday objects, such as a butter knife, a hammer, and a pair of scissors. These are all good examples of simple machines. They have one or two parts, and they help you do work, such as spreading peanut butter, removing a nail from a wall, and cutting paper. Bulldozers and airplanes are compound machines. They're made up of many parts, including two or more simple machines. Other common compound machines include an electric pencil sharpener, a lawnmower, a car, and a steamboat. Machines make doing work easier. Machines help people do work by reducing the amount of force needed to complete a task. You have probably seen a ramp attached to the back of a truck. It is a simple machine that makes the work of loading objects into the truck easier. The force needed to push objects up the ramp is less than the force needed to lift the same objects. Because less force is required, the task is easier. A ramp reduces the force needed to lift an object by increasing the distance over which the force is applied. When you push something up a ramp into a truck, you cover more distance than the distance from the ground to the truck. Still, the task is much easier to complete. Friction and machines. For a machine to do its job, work must go into it. Work comes from you when you carry your books upstairs. It also comes from you when you sweep the floor. Work can sometimes go into a machine from a different energy source. Some machines, such as the washing machine that cleans your clothing, are powered by electricity. Do you think the amount of work a machine does is the same amount of work that goes into it? Actually, a machine does less work than the amount put into it. The main reason for this difference between input and output is friction. Most machines generate heat when they are operated. Most machines have many movable parts. Heat is the result of friction between the many parts of the machine. For example, machines with many moving parts, such as cars, lose a lot of the input work to friction. This is one of the reasons the car's engine and its other moving parts need to be properly lubricated. Lubrication reduces friction. People who design machines try to reduce friction and the loss of work as much as possible. Reducing friction saves energy and decreases the amount of work that must go into a machine. Types of simple machines. Let's take a look at how the different types of simple machines help you do work. There are 6 basic types. Lever. A lever is one or more bars resting on a support, or fulcrum. The lever is used for applying force, such as lifting a weight. Recall that a hammer used to pry a nail out of a wall is a simple machine. It is one example of a lever. The curved part of the hammer's head is the fulcrum. The nail, or load, creates a force on the hammer. The force applied to the end of the hammer's handle is called the effort force. When effort force is applied to the handle, it pulls up on the load. This pulls the nail out of the wood. It is much easier to pry a nail out of wood with a hammer than by hand. A fulcrum can occur in different positions on a lever. The closer the fulcrum is to the load, the less force is needed to move the load. The closer the fulcrum is to the effort force, the more force is needed to move the load. When the fulcrum is close to the load won't be lifted very high. But when the fulcrum is close to the effort force, the load will be lifted higher. Levers fall into the following categories. First-class lever. In a first-class lever, the effort force is located at one end, the load is at the other end, and the fulcrum is in the middle. A pair of pliers is an example of a first-class lever. Second-class lever. An example of a second-class lever is a nutcracker. The fulcrum is at the closed end. You apply the effort force to the handles, and the load is the nut you're cracking. Third-class lever. In a third-class lever, the fulcrum is at one end and the load is at the other. The effort force is in the middle. A pair of chopsticks is a third-class lever. Inclined plane. Remember how a ramp attached to the back of a truck helps people do work? A ramp is a type of simple machine called an inclined plane. It's a slanted surface that makes moving a load from a low place to a higher place easier. Other examples of inclined planes are the slide you see at many playgrounds and the wheelchair access ramp you can find at many public buildings. Yet another example is a road system that winds up a steep mountainside. You have to travel a greater distance to get to the top of the mountain than if you had gone straight up. But less force is needed to move the car along the twisting road, so it makes the work easier. Wedge. A wedge is a simple machine made up of one or two inclined planes. Its point is often called the blade. Examples include an axe and a knife. A wedge pushes objects apart. A wedge can only do this if it is moving. Someone has to swing an axe to make it chop wood, and someone has to move a knife to make it cut through meat. Screw. A screw looks a lot like a nail with ridges. Those ridges are called threads. A screw is actually an inclined plane that wraps around a cylinder. That is what forms the ridges. A screw works by increasing distance and decreasing force. You can put a light bulb securely into a socket by screwing it in. The ridges let you fasten it tightly with less force than if you push directly, but you have to apply the force over a greater distance. The handle of a faucet is a wheel that turns an axle. Wheel. The wheel is larger than the axle. This means that the force used to turn the wheel turns the axle with an even greater force. Axle. Only a small amount of force applied to the wheel is needed to turn the axle. When the axle turns, the tap releases water. Wheel and axle. A wheel and axle is a wheel with a rod called an axle through its center. A Ferris wheel is an example of a big wheel and axle. You've probably ridden on one at a carnival or fair. A smaller example of a wheel and axle is something you use every day, a doorknob. How does a wheel and axle do work? The axle attaches the wheel to the object it is moving. The axle turns when force is applied to the wheel, and it is more powerful than the wheel. So when you turn a faucet, the force you apply turns into a greater force in the axle inside the knob. The force from the axle is what operates the tap and opens the faucet. Other examples of the wheel and axle can be found in cars, bicycles, clocks, roller skates, and faucets. Fixed pulley system. The pulley wheel is fixed in one position. The load is attached to the rope. Pulley. Have you ever seen a crane lifting large objects at a construction site? That's an example of the simple machine called the pulley. A pulley is a grooved wheel with a rope, belt, or chain around it. You attach a load to one end of the rope and apply effort force to the other end. In other words, you pull on the rope, causing the wheel to turn and the load to move. The point is to make moving the load easier. Pulleys can be fixed or movable. As the wheel turns, a fixed pulley stays in one position. Think about seeing a flag raised on a flagpole. You pull down on the rope to move the flag up. The fixed pulley doesn't move or reduce the effort force needed to raise the flag. It simply changes the direction of the force. A movable pulley is attached to the object being moved. It decreases the effort force, but you must apply the force over a greater distance. Compound machines. Most of the machines you come across every day are compound machines. That means they are made up of two or more simple machines. Examples include the stapler you use to fasten papers together and the can opener you use in the kitchen. More complicated examples are your watch, the school bus you ride, and the airplanes that buzz overhead. Compound machines can have hundreds or thousands of parts. Have you ever seen a sailboat up close? It's a great example of a compound machine made up of many simple machines. Here are examples of all 6 types of simple machines in a sailboat. A sailboat is a compound machine made up of many different simple machines. Inclined plane. The jib sail, or jib, is an inclined plane. It directs the wind to the bigger mainsail. Pulley. The winch is a type of pulley. The rope end hoists weights and raises or lowers the sail. Lever. The boom is a lever with a fulcrum at the mast joint. The weight of the sail above it is the load. Force is applied by the guide rope. The rope controls the direction the boom swings. Wheel and axle. The helm is a type of wheel that can change the direction of the rudder. Wedge. The rudder is a type of wedge. It sticks out below the rear of the boat and helps steer it. The keel is another example of a wedge on a sailboat. It keeps the boat moving through the water in a straight path. Screw. The propeller is a type of screw that pushes some sailboats through the water.